Hello everyone, this is Balaji K.R. signing in for Brain Smart Labs. Yesterday we kickstarted OOPS with a grand opening. Honestly speaking, OOPS in general is not that difficult to understand.
Oh really?
It is very easy as it follows all the properties of Mother Nature. Founders of Java have embedded the concepts of nature so brilliantly, it has been almost 25 years and still Java is unshakable in today's software industry.
Wow!
The reason why it is more stable because it derives all its strength from OOPS whose concepts are directly derived from Mother Nature. More on OOPS concept we'll be seeing in today's class, and before we enter that, let us take a quick recap on what we did in our previous session. In our previous session, a big intro to OOPS, we gave you the definition of a programming model which says it is a feature given by a programming language that describes the methodology of coding. We saw OOPS as a programming model implemented in Java language which helps it to achieve the reusability and also to avoid complexity. The concept of OOPS was explained to you using a building plan, where a plan in real life acts as a mere template and any house built using that plan becomes an instance or an object. We understood the advantage of creating a plan in the first place, as using that plan, same house can be replicated in multiple cities again and again. OOPS in Java was explained using a class box template, and this template was later given life by creating a new box object. Here we understood members present in a box object can be reused by a programmer any number of times after its creation. Usage of members here include accessing the instance variables LBH to print the values, accessing the instance variables to alter the present value, and last but not the least, invocation of methods present inside your box object. In our previous class, we also saw what is a dot operator in Java, and here we understood how does it work to access members, without which we cannot work in OOPS. In today's session, let us first start seeing an important interview question: difference between a template and an object.
Difference between a template and an object.
A template is an entity which describes only a plan or a mold, whereas an object is one such instance of that plan which is brought to life in real time. A template always exists as a single entity, whereas multiple objects can be created n number of times using a single template. A template does not die as it does not have any life, whereas an object that is created or an object which is given life using that template has to die at some point of time in our program. You can create n number of templates without creating any object, whereas you cannot create any object without having an existing template. Well, these are the points you need to tell if they ask this question in your interview.
Okay.
Not just the above, there is one more important difference between a template and an object you all need to understand. From here on, the class box what you write as code will be known as the box template, as it contains the blueprint of an object, and this blueprint code cannot be used by us directly. Whereas a box object which gets created inside our JVM is a real object that has life, and only this object can be used by a programmer in his programs. The code what you see to your left is nothing but a plain piece of template which is present inside your hard disk, whereas the object what you see to your right is nothing but a virtual instance of this code present in real time inside your JVM memory. The variables declared inside our box template are known as instance variables, that is int_l, int_b and int_h. These variables are also called as states present in an object. Below these states, we have declared two instance methods inside our class box. These instance methods in Java are known as behaviors, which contain the code to perform some action inside our object. Guru, Just now you said instance variables are nothing but states in Java. Is it similar to states of Andhra, Karnataka and Tamil Nadu? Lo pedmundede. The word states in English does not only mean United States of America or any state you see in a country's political map. State in English also mean properties. In Kannada you call it vastusthiti, which determines the condition of an entity. For example, you say the three states of matter are solid, liquid and gas. Here the word state represents condition of the matter, also known as vastusthiti, not some stupid boundary. Artha aita? Oh, hange. Artha aitu. Why all that? I will take the example of your class box only. The states here, also known as instance variables LBH, which represents length, breadth and height, determine all the characteristics of your box object. Anything related to box you want to calculate, like volume, surface area, etc. Only these three states, that is length, breadth and height, play an important role in your calculation. In your box, everything will be calculated based on these three variables, and so they are called as states of an object. States always define the condition of an entity, and that is the reason why in Java, instance variables are known as states, which determines the vastusthiti of an object. States means instance variables, okay. Why do you call methods as behaviors? Is there any reason? In Java, instance methods what you declare inside a class template are also known as behaviors.
Okay.
The reason being, only behaviors can determine the action or how the object should behave when these methods are invoked during runtime. Like for example, print volume method is a behavior inside box object. This method, when invoked, calculates the volume of the box during runtime and prints it on screen. When this method was invoked, all it exhibited was a behavior which was programmed to behave in such a way inside our box object. Likewise, you have one more method by name fetchSurfaceArea, which calculates and returns the surface area of an object during runtime, which is another behavior exhibited by our object. So in your interview, if they ask what is a class template, your answer should be: a class template is an entity which holds the complete information of an object. The information mainly includes number 1, states of an object, which defines the properties present inside the class that describes every object of this template. Number 2, behaviors, which defines all actions performed that can be invoked inside every object of this template. In other words, a class template acts as a DNA that contains the complete information of an object which will come to life in near future. Ultimately, if they ask you what is encapsulation in Java, you should answer: the process of storing information of an object inside a class template in the form of states and behaviors is known as encapsulation. For example, in our class box template, we have encapsulated information about a box in the form of 3 states, that is L, B and H, and 2 behaviors, that is method print volume and method fetch surface area. After seeing this definition of a class template and encapsulation in OOPS, now it is a time to see industry standard conventions for naming a class.
Okay.
Industry standards.
The following are the industry standard conventions for naming a class. Number 1. A class name in Java should always be a valid identifier. Number 2. In general, a class name given by a programmer should always be a noun. Number 3. A class name in industry should always start with capital letter followed by camel case if multiple words are present. For example, Taj Mahal is a 2-letter word, and to name a class Taj Mahal, you should use camel casing with T letter as capital as seen over here. Likewise, you can name a class as account service bean with camel case starting with a capital letter A. You can also name a class as action servlet using camel case starting with a capital letter A. Last but not the least, Number 4. A class name should not contain any digits or special symbols unless you are forced to. This usage is very rare. I have repeated this 1,000 times, still I am repeating, follow the industry standard conventions in programming as it is a must. If not, you will not get any compilation error, but the code what you write in the company will be maintained by someone else later in that project. If you don't follow these conventions what I am teaching, you will be thrown out of the project as the other developers cannot understand your code.
Oh no!
I have seen many candidates in a company, especially freshers.
Oh really?
They will tell they know Java, but do not follow these conventions which are universally accepted by all developers. Forget conventions. They write their code so shabby, there will be no proper line spacing or tab spacing or any sort of indentation. They will start a class from this line. They will also start a flower brace from this line. Then they will start a method also from this line. And later they will write the entire body on this line. Now you only tell me, will this look like a code from any angle? ಅಕ್ಷರಗಳನ್ನ ಯಾವುದೋ ಡಬ್ದಲ್ಲಿ ಹಾಕಿ ತುರ್ಕಿಟ್ಟಂಗಿದೆ. Nonsense. If I was your project manager, I would have blasted you left and right if you had written code like this.
Oh no!
Seriously, people like this don't deserve any position in a company. ಕ್ಯಾಫೆಟೇರಿಯಾದಲ್ಲಿ ಟೀ ಕಾಫಿ ಹಾಕಕ್ಕೂ ಲಾಯ್ಕಿಲ್ಲ. ಹಲೋ, ಏನ್ ನಗ್ತಾ ಇದ್ದೀರಾ? For that position also they will expect some neatness, else they will throw you out from that place. This is my last warning. Never write code like that. The code should be exactly the same what I show you on screen every day. If I have given one tab space, even you should give one tab space. If I use two tab spaces, even you should use two tab spaces. Suppose if I start a class name with a capital letter, it means even you should start a class name with a capital letter. Suppose if I am using camel case for class names, variable names and method names, even you should use camel case in your source code. If you stay very adamant and write the code as per your whims and fancies, tomorrow nobody will understand what you have written and they will throw you out of the company. Oh no! Practice from now for you to survive tomorrow. Follow all the industry standard conventions what I teach. Arthaita? Now it is time to understand what is new keyword in Java. Pay your full attention.
Understanding new keyword.
A new keyword in Java is an operator used in OOPS to create new objects of existing templates. For example, the below template contains a code for our class box. During runtime, when our program says new box, a new box object will be created. If the program says new box once again, another box object will be created inside our JVM. Likewise, if the program says new box one more time, one more box object will be created which is totally independent of the other box objects which are already present. Like this, we can create n number of box objects using the statement new box inside our JVM. In simple words, using the code new box, you are creating multiple objects of type box wherein the class box what you have written acts as a user defined data type. User defined data type. Now what is that? To understand what is user defined data type, let us see the following illustration.
Understanding user defined data types.
Consider a statement int I equal to 25. Here int is a primitive data type. The letter I what we have used here is a variable name and it is a valid identifier. Equal to symbol is the assignment operator which assigns values from right hand side to left hand side. And 25 is the literal value which is to be transferred inside primitive int variable I. Now consider the statement box B is equal to new box. Here in this statement, the word box indicates class box which is a user defined data type. Variable B is nothing but a variable name which is of course a valid identifier. The equal to operator is the assignment operator we use to transfer the address of an object from right hand side to left hand side. and the code new box what we have written on the right creates a new box object in our JVM memory, returns the object address which will be later transferred to variable b present here on the left hand side. If in case you are confused who is the user here, the user is you. What? Yes, you are the user who has defined what is class box, and so box is a data type created and defined by you in your program. Oh yeah! By this we can understand a class template what we write is nothing but a data type defined by a user. Hence it is called a user defined data type. In simple words, if you want me to explain, consider a box template existing in your source code. You write the code box b equal to new box which creates a new box object during runtime. Now as the code for class box is written by a user which will be later used by us to create multiple box objects, class box can be called as user defined data type. Likewise, if you can create cat objects using a cat template to your left, class cat can be called as a user defined data type. Similarly, if you can create dog objects using a dog template to your left, class dog can be called as a user defined data type. Imagine, using a primitive data type by name int, you can create thousands and thousands of int variables wherein all can store pure integer values.
Really?
Likewise, using a primitive data type by name double, you can create thousands and thousands of double variables wherein all these variables can store a double precision floating point value.
Oh.
Similarly, using a user defined data type by name box, cat and dog, we can create thousands and thousands of variables wherein all these variables can store the addresses of box objects, cat objects and dog objects respectively.
Okay.
An int variable in Java can hold only integer values. A float variable in Java can only hold floating point values. Likewise, a box variable b can only hold the address of box objects in OOPS. Similarly, a cat variable c can only hold the address of a cat object, and a dog variable d can only hold the address of a dog object. The variables b, c, d are known as user defined variables in Java. Bravo! Guru, user defined data type andre gotaito. But what is the relation between a user defined data type and a user defined variable? Can you please explain that? Yeah, sure, why not? Let us start understanding more about user defined variables.
Understanding user defined variables.
Consider a statement box b equal to new box. Now this statement can be broken down into two different statements in Java. One statement is box b and the other statement is b equal to new box. Similarly, for a statement cat c equal to new cat, you can separate it as cat c in one line and c is equal to new cat in the other line. If you choose to split the statement dog d equal to new dog, dog d can be written as a separate statement and d equal to new dog can be written as a separate statement. This style of splitting can be done while declaring your primitive variables.
Oh, really?
Here, int I equal to 25 can be written as int I in one line and I equal to 25 in the other line. Likewise, floatf 3.147f can be written as floatf in one line and f is equal to 3.147f in the other line.
Okay.
Here in these examples, box b, cat c and dog d, the phrase box, cat and dog signifies user defined data types and variables b, c and d are known as user defined variables. In simple words, a variable declared using a user defined data type is known as a user defined reference variable. A user defined reference variable in Java is used to hold the address of its respective object. Whoa! Declaring an object is just like declaring our primitive variables. Nice, nice. Now I clearly understand. Now take the example of building a house. You will understand the concept even more clearly. Before building any house using a plan, we analyze the plan and choose a suitable building site to build our house. Now suppose if we construct the house according to the plan in this location, the location where we have constructed the house will have an address and a postal pin code. The point you need to understand here is every site location on earth will have an address location, and so every house constructed on any site belongs to that address. If we relate the same example for creating an object, a class template in Java is nothing but a plan which describes how our object should be. When we create an object using the new keyword, a new object that gets created will be present in the location by name JVM heap memory. The object which gets created inside our heap memory will have a defined memory address location where the object is exactly present. This memory address can be related to the site address of our house, and it is called an object address in Java.
A house built using a plan has an address. A house built using a plan always has an address. Likewise, an object created using a template always has an address. Wow, super Guru. Can you tell more about this object address? Sure, take a look.
In Java, when we write a statement box B in the first line and B equal to new box in the second line, the first statement always say that we are declaring a variable B of type box. When our second statement B equal to new box gets executed, a new box object inside our heap memory gets created with a valid memory address understood only by our JVM. After the object is created, an interesting thing happens. The object address of our box object created on the RHS will be then transferred to our variable B present on the LHS.
The same process will hold good for our cat and dog objects too.
When the statement cat C gets executed, a variable C of type cat first gets declared. In the second statement, when you say new cat, a new cat object will be created inside our JVM heap memory with an address which is understood only by our JVM. Now, after the creation of object happens in our RHS, the address of this object will now be transferred to our variable C present on the LHS. Now the same principle will hold good for our code dog D is equal to new dog. Here the new dog statement present on the RHS instructs the JVM to create a new object inside our JVM heap memory. As you can see, the object which gets created completely bears a different address, and this address will now be assigned to our variable D, which is currently declared on the LHS.
That and all okay, Guru. I am worried about the size of our variables. We know our primitive variables int and float are of size 32-bit. Likewise, primitive variables double and long are of size 64-bit respectively. Now what is the size of our user-defined variables, that is box P, cat C and dog D?
Well, if you are asking me the size of a user-defined variable, the size of any user-defined reference variable in Java which stores the address of an object is of only 2 bytes.
What? Only 2 bytes? Yes, only 2 bytes.
Variable B of type box is of only 2 bytes. Likewise, variable C of type cat is also of only 2 bytes. Similarly, variable D of type dog is of only 2 bytes.
Many students, I mean it, many students will have a misconception that when we say box P is equal to new box, object itself will go and sit inside our variable B. Yes! If you have such thoughts, simply throw it to the dustbin.
Object reference in Java is just a plain address which moves from RHS to LHS after the creation of an object. In a program, if we declare variable B of type box and then we write the code B is equal to new box, the new box code triggers the JVM to create a new object of type box inside our heap memory. Many people think when this happens, the object itself will move from right hand side towards the left hand side. This is completely wrong, as it is practically impossible for the JVM to transfer such bulky objects inside this 2 bytes of memory. Objects in Java are always created in the heap memory. The current memory address where the object is located will now be transferred to variable B after the creation of our object. And so, as the variable B holds the address of the current box object, it will now start referring to the same present inside the heap memory inside our JVM. Same principle will apply both for our dog object and cat object. When the above statements get executed, both dog object and cat object gets created inside the heap memory. Each object created in the JVM will have its own unique memory address, and this address can be understood only by our JVM. These addresses where the objects are located will now be transferred into our variable D of type dog and variable C of type cat respectively. From here on, these variables will now start referring to the below dog object and cat object as they hold the object reference of dog and cat respectively.
Wow dude, that's simply amazing. For a moment I had thought the object itself will go and sit inside our reference variable. But no, you're right. How can a reference variable of size 2 bytes hold this big object? Address means yes, it can easily be stored in a 2 byte location. Super! Excellent! But now I have a question. What is the use of storing an object address inside these reference variables? Does it help us in any way? Of course it is useful. The only point of link you have to access the instance variables and methods present in your object is via a reference variable and a dot operator. Take a look.
Dot operator access in Java.
Consider a statement box B is equal to new box. As the statement gets executed, a new box object is created inside the JVM heap memory, which is now referred by our one and only reference variable B. Now using this reference variable, we can access any member present inside our box object whose reference address is stored inside this variable. For example, if I want to change the length of the box to 10 units, I just need to say b.l equal to 10. And boom, the variable by name L will get instantly altered to numerical value 10 after the above statement gets executed. Likewise, if I want to change the breadth of the box to 20 units, I just need to say b.b equal to 20. And boom, the variable b inside the object will get updated to numerical value 20, erasing the old value which was present inside. Similarly, if I want to change the height of the box to 30 units, I need to say b.h is equal to 30. And boom, the variable by name h will get replaced with a new numerical value 30 as the above statement b.h is equal to 30 got executed. If I want to invoke print volume method in this object, all I have to say is b.printVolume. And boom, the print volume method gets loaded into the stack, and here it will be executed instantly for us to see the output.
Guru, print volume method gets executed when we say b.printVolume, okay? We can see the output here and we are convinced. But my question is, how to execute fetchSurfaceArea method? We have to catch the integer result and then we have to print the value, na? How to do it? You're right. In case of invoking our fetchSurfaceArea method, we have to add an additional step for us to capture the result and print the output.
In the first line on the right hand side, we invoke the method by saying b.fetchSurfaceArea. On the left hand side, we declare an integer variable which will store the result which is to be returned from the method. In the consecutive line, we print the integer variable using an SOP statement, as this variable holds the final result which will be returned by the method invocation b.fetchSurfaceArea. Now during runtime, the method b.fetchSurfaceArea gets loaded onto the stack. When the method completes its execution, it gets removed from the stack after returning the processed output. The final processed output of this method is now transferred to the variable on the left hand side with the help of an assignment operator equal to symbol. The output of this method gets printed on screen as the SOP statement in the second line gets executed over here.
Guru, should our result variable be named only as int box surface area, or it can be named anything else? Who told it should be of same name? You can literally name your variable anything you want.
Oh, really?
For example, your result variable can be named as int SA, int BSA, int ABC, int X, or any name given by you for you to choose. Your program will definitely run successfully and you will get the result. Simply amazing. We once create a template and later create objects of the same to use it in our program.
Yes!
But dude, I have a question. What is the mystery behind this box object? What actually happens at the back end? To know what will happen when you execute the program, let me reveal you the real mystery behind our box object.
Mystery behind our box object.
The program what you wrote yesterday is nothing but a source code written on a simple text file. When you compile this program by pressing Ctrl 1, after successful compilation on your hard drive, two more files will be created. One will be demo.class and other will be box.class. This box.class file we just got generated is nothing but a template for our future box objects. Now inside our class demo, if we type the code box b and b equal to new box in line number 22 and 23, we are ready to create our first box object. But remember, as we have altered the source code as a general practice, we have to compile the code one more time to regenerate the bytecode for our program. Now it is time to run the code by pressing Ctrl 2. The program control will now start executing our main method starting from the line number 20. In line number 22, when your program says box b, as we are declaring the box variable for the first time, the box.class present inside your hard drive gets loaded onto your JVM. When the program control reaches line number 23, as we have written b is equal to new box, a new box object gets created inside the heap memory present in our JVM inside a specific address location whose address will now be stored inside our variable b. The object now contains all states and behaviors clearly described same to same as present in the template, that is variable L, variable b, variable h, print volume method, and last but not the least our fetch surface area method.
Wow, ultimate bro. The process flow behind creating a box object is simply amazing. I have one more question. How can we create multiple objects of type box? What are the changes we need to do in our program to create multiple box objects? To create multiple objects of type box, you need to make a little bit of changes inside your main method. Take a look.
Multiple objects of type box.
To create multiple objects of type box, we need to just add few more lines inside our main method. We are trying to create 3 box objects here using the phrase new box 3 times, and each time over here we are transferring its address to 3 different reference variables, box b1, box b2 and box b3. Now it is a time we recompile the program by pressing Ctrl 1 and execute our program by pressing Ctrl 2. And kaboom! The program control starts executing our program from the main method. As it reaches line number 23, a new box object will be created in our JVM heap memory as shown here. if you can observe, our variable b1 will be holding the reference to our first box object, as we have written the code box b1 is equal to new box. Similarly, when our program control moves to the next line, that is line number 24, another new box object is created in a different address location whose reference will be given to our variable b2. Now as the program control moves to line number 25, one more new box object will be created again at a different address location, and this time the reference of this object will be given to variable b3, as we have stated in our program box b3 is equal to new box.
As you all can notice, we have successfully created 3 different objects in 3 different memory locations with 3 reference variables holding the address of these objects independently.
Yes!
Before me winding up this topic, I request you all to write down every piece of code what is being taught over here.
Okay.
Without writing the code and practicing the same after this video, nothing will remain in your head, as everything will evaporate very soon. I can challenge you anywhere, if you don't code and watch this video again after 3 days, everything will be appearing new as the topic would have already evaporated from your head. So it is my sincere advice to all of you, make notes of all classes correctly and code all the programs what is being taught to you for everything to stay inside your head forever. Guru, you know what? There is nothing to code today. Yesterday you created one object, today in the end you created 3 objects. What big changes are there for us to code once again? It is just theory topic, no? I know everything. Makada, I know you will tell this. That is why I have designed a wonderful assignment for you to test your skills.
Really?
Note it down and practice with good faith.
Mini assignment.
Write the code inside your main method to complete the following tasks. For the first object box b1 is equal to new box, print the volume of b1 object in the first line and then print the surface area in the next line. For the second object box b2 is equal to new box, using valid SOP statements, print the values of LBH that are present inside. Change the values of LBH to L is equal to 10, B is equal to 20 and H is equal to 30, and after this, using valid SOP statements, print the values of LBH of our B2 object to verify whether the values have actually changed or not. For our third object box B3 is equal to new box, print the current volume and surface area of the object B3 in the first few lines. Now change the values of L to 25, B to 35 and H to 45 using the given reference variable B3. Print the volume and surface area of our B3 object again after changing the above values.
And that completes our second session on understanding encapsulation. In tomorrow's class, we will be seeing more about user-defined variables. Do text us your doubts on WhatsApp if you have any, so that we can solve it for you. Remember, you understanding the subject is our topmost priority. Do refer your friends to buy this series on our website www.brainsmartlabs.com, which will financially aid us to bring more and more videos for you. Until then, this is Balaji KS signing out, and you know what to do. Muchkond kodu ಮಾಡಿ, bye bye.